Okay, pre-cal, we're going to talk about graphing polynomial functions, so hold on to your seats. All right, there's a lot involved here, but it's not terribly difficult. It's just a little tedious. So when we're graphing a polynomial function, the very first thing we're going to do is find our end behavior, okay? At page 4 of your notes here, graphing polynomials kind of brings the first 3 pages of your notes all together. Like, oh, that's why we did that. That's why we learned that. That's where we are. All right, so we're going to find the end behavior. Remember, we talked about that when we talked about the dough chart, right? Talk about the degree and whether or not it's even or odd and whether or not the leading coefficient is positive or negative. We're going to use that. And then that kind of gives us an idea of sketching what the end behavior is going to look like. Because when we're graphing these, if you'll notice, I don't have any grids here. I don't have any graph paper. These are just freehand, all right? They don't have to be perfect. You just have to have all the turns in and crossing the y-axis at the right place and all that. Okay, so we're going to plot the y-intercept. All right, that's why I had you find the y-intercept on those your last homework. Okay, we're also going to find the zeros, so we'll know where it crosses the x-axis. And of course, we will make a sketch. And like I said, it's not a detailed, accurate drawing. It is just a sketch. All right, so there's several things we have to look for here. So if you will look at example 1, we're just going to go ahead and dive in. And by the way, if you're not great at factoring, you're going to struggle with these. So I highly recommend looking at the factor video, and I can give you some extra practice if you want it. All right, so we are going to start in the obvious place. We're going to start with our degree. That's the easiest. So if you'll notice, our degree here is 4, so that is an even number, and our leading coefficient is positive 1. So if I've got an even degree and a positive leading coefficient, that means my end behavior is up. So I know that no matter what this graph does in between, it's going to have end behavior like that. All right? Who knows what it's doing in between those two end behaviors, but I know where it's going to end up. All right, the next thing we're going to talk about is the y-intercept. Now remember, we talked about this. If we've got a constant here, that's our y-intercept. So how do we do that? Well, I'm just going to make a mark on the y-intercept and label it that value. Okay, so this ordered pair right here, yeah, let's use an ordered pair. I don't know what I was thinking. So this ordered pair is 0, 16. So that's the next thing I'm doing. Okay, see, I'm building my graph. All right, the part you're not going to like. We need to take our original and we need to factor it because we have to solve it. This one factors pretty easily. All right, we have x squared minus 4 and x squared minus 4. And then those will each factor again into x plus 2, x minus 2. Don't forget to do both of them. This is important because of that idea of multiplicity that we talked about on the last video. All right, so as you can see here, I've got 4 factors. That means I'm going to have 4 solutions, which makes perfect sense because my degree is 4. That's how many solutions I will have. All right, so what do those solutions look like? Well, I'm going to change each of these to zeros. So I've got -2, 0. There's one there, and there's one there. So I've got multiplicity of 2. And I've got x minus 2 and x minus 2. So I've got multiplicity of 2 for 2, 0. So I'm just going to mark those on my graph here. There's 2, 0. And there's -2, 0. You should already have an idea of what the graph's going to look like there. Because if I've got multiplicity of 2, the graph's going to come down, bounce off of that, and go back up. All right, so it's not going to cross all the way through the x-axis. It's just going to touch it. All right, the last thing I need to know how many turns this graph is going to have. Well, since my degree is 4, there will be 3 turns. All right, so what is that going to look like, Miss Griggs? Well, I'm going to come over here to my graph and I'm going to tidy this up a little bit. Okay, I'm going to erase my end behavior. I already know what it's going to do, so that's what I need. Okay, so remember we talked about the idea that this has got a bounce here. All right, so I know it's going to do something like that, and I know my graph has to go through 0, 16. And I know it has to have 3 turns, so 1, 2, 3, just like that. All right, so there's my up behavior. So let me show you again in another color so you can see what I'm talking about here. Okay, so listen to my turns. Okay, I've got 1 turn, 2 turns, 3 turns. See how that works? There you go. That's all you got to do. Easy peasy, lemon squeezy. I know, right? Let's use another color. Let's get crazy. All right, let's go to number 2. And I'll probably break these down into more videos because it's going to be too long. Okay, so as usual, I start with my degree. Well, my degree is 4 again, and my leading coefficient this time is a -3. That means that I've got even degree and negative leading coefficient, so I've got down behavior. So I know whatever my graph does in between all of this, I know that it's going to be headed down in both directions. All right, so I'm going to look at my y-intercept. If you'll notice, we don't have a constant here. That's an indication that we are going through 0, 0. Okay, so I'm going to factor this. If you'll notice, we've got a -3 in both of these and an x cubed, so I'm going to factor out the GCF. So -3 x to the 3rd will leave me with x plus 4. Okay, so now I've got 2 factors here, so I'm going to set each of the factors equal to 0 and solve. All right, be careful right here, babies, because x cubed equals 0. That means I've got to take the cubed root. The cubed root of 0 is 0. But what you have to remember here is that since it's a cube, okay, go back and look at your degree. It's 4. So how many solutions should there be? There should be 4 solutions. Well, I know this x plus 4 over here. I know when I solve for it, I get x is -4. So that's one of my zeros right there. I need 3 other answers. Well, x cubed equals 0. There are 3 more answers at 0, 0. So it's got multiplicity of 3. Okay, that's how that works. All right, so the y-intercept goes through the 0, 0. I've got a value at -4, 0 right here. All right, so what is my graph going to look like? Let's see how many turns we have. Since it's got a degree of 4, we're going to have 3 turns. Okay, this one is a little trickier than the last one because of this multiplicity of 3 right here. Because here's how multiplicity works. If your multiplicity is an even number, it will sit on the graph. If your multiplicity is odd, it will go through the graph. But it goes through the graph in a weird way. It goes through the graph, well, I'll show you. Okay, so what is this going to look like? Well, I know I'm going to have 3 turns, and I know what my end behavior is. So I'm going to erase these arrows here. So I know it's got to do this, and then turn, 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 turn. There you go. That's what it's going to look like. So I go through -4. Okay, so I'll do it in another color again so you can see. So up through there, turn, turn, turn. All right, see how that flattens out right there at 0, 0? That's because we have multiplicity of 3 right there. Okay, we're going to do the other examples in another video.